So this is not a ham radio related video, and it's a follow on from a short that I did regarding this Ramsey Electronics AM-25 broadcast transmitter. If you haven't seen the short, basically a friend is visiting from the States. He purchased this on eBay and asked if I could have a look at it. Messages that he was having before buying it, the seller confirmed that he was running it a bit more higher power than what its Part-15 is. And when it did arrive, there was a link between R34 and 33, and some of the components had been changed. In the manual, it does state you can do that if you were using it outside of America. Puts it into export mode and does about 1 watt. You also, if I just flip it over, you can just see slight discoloration where the transmitter has been running at a watt or roughly, and it's slightly discoloured the board underneath. You can also see it on the top underneath these heat sinks. As I mentioned, some of the components have been changed. So one of them was Q9. They had a 2N5490. I've replaced it with a tip 31 as per the manual. Q3, they had an NTE 2390, and the original one for the manual was a P16NF06. So I've replaced that for that one there. And Q5 over there was a NTE 123AP, and the original in the manual showed a 2N3904. So I've done those bits for him. I've also done the low pass filter. He wants to run it on 1610 kilohertz. So as per the manual, I followed the instructions, rewound those coils, changed some of the values of the capacitors and removed what wasn't needed. Most of these units, because this was designed, manufactured and produced between 1996 and 2014 roughly, most of these units are all built. You might find on eBay the odd one that isn't built, but if you've got a built one and you want to make sure it's aligned properly, because some people just turn up all the pots and hope for the best, and that necessarily doesn't mean it's working well. There are a few modifications people have done, changing capacitors, putting actual IC holders. These ones have actually been soldered to the board, so you'd have to unsolder it all to get the ICs out. So if you've got a kit version, I'd recommend putting the IC holders in. I've also replaced the heat sinks for better ones. Even though he's running at 100 milliwatts, I thought it was not going to do any harm giving him better heat sinks. What we're going to do, if you've got one of these units, you need to obviously set the frequency via this dip switch, and it's a binary code. So if we have a closer look at the board, underneath here you've got a load of numbers here along the dip switches. So in the manual, if you have a quick look, it gives you a couple of examples: 1550, 1520, 1460, sorry. So for argument's sake, if you want it on 1520 kilohertz, you need to get to 152. And how you get that is the frequency, 1520, divided by 10, 152. So that means the dip switch is 128, 16.8, which adds up to 152. You just need to put that on there. So as my friend wants it for 1610, I've put the dip switches of 128, 32 and 1, and that puts it on 1610. There's a slight alignment process you need to do. We need to adjust the BIOS and we need to adjust L1, and there's a couple of voltages that need to be done. So I'm just going to connect this up to the multimeter. We've got the watt meter over here as well. This is going to be connected to a dummy load. So I'm just going to plug all that in, and I've also got a frequency counter here. We're going to check the frequency once I sort the alignment out. So bear with me while I connect that all up. So I've all got it connected up. Coax that goes into the watt meter. We've got the multimeter. I'm using a phono. As I'm using a regulated wall wart, I needed a ground point, so that's connected on the phono onto the audio. So the first thing we need to do is, I'm going to turn it on. We're going to see the LED come on. You might see some output. There we go. So it's on the 1 watt scale. I'm just going to move it over. So already we're seeing just over 100 milliwatts. But we're going to check to make sure. This meter here, I don't know if it's 100% accurate, but it's close enough. I've used it on my amateur radio gear. So what we need to do is take a measurement on R34, which is that resistor there. So if we take a measurement, we need to get that value up to 7.1. So we're reading 5.8, and we just need to adjust this control here, this pot. So let's adjust that. Do we see close enough? 7.1. Bit overshoot. Let's just try and bring it down a little bit. Too far now. Let's go back the other way. Close enough. 7.11. Let's change it over. So it's showing, again, I don't know how accurate this is, but it's showing nearly 200 milliwatts. We also then need to adjust L5 here with, there's the test point. You see that little, I think someone's used a bit of a lead off a component or resistor. So that needs to be set between 1 and 3. So if I get there, that's quite high. So that's just it says use a plastic trimming tool on this one actually. So let's get that onto there. As you see, it's coming down now. Right, you just got to be careful you don't go too far with the core and pull it right out, but let's see how low we can go. Yeah, so I'm starting to feel that core sort of being on its tail end. So let's go for about there. So that's brought that down a little bit. Again, we've got to take it with this with a pinch of salt, but it's giving us a bit of a rough guide. So if I go across, I'll bring that in a bit more. We're reading this top scale now, and it's gone past the 100 milliwatt, maybe 150 milliwatt. That's that alignment there, as long as you get those voltages correct. So you've got R34, 7.1, and then anywhere between 1 and 3 on that test point. Just show you that in the manual. We've already done a low pass filter. We set those to a rough range, and then adjust the bias pot R23 for 7.1. So that's that one. And then on the next page, it says, using a plastic trimming tool, adjust L5 until you read between 1 and 3 volts at test point 1. You should also see the red LED light up and able to hear a carrier. Well, we can see we've got output, we've got the LED lighting up, and we've got the right voltages. If I just switch it off for a second, and we're going to take that off. I'm going to plug this up to the frequency counter. Just be careful when you're doing this, you don't short between the two. Right, hopefully you can see. Got the frequency counter on. We're at 161018. I'll just take my tool and this variable trimmer there. We're just going to adjust that to see if we can just bring that in a bit more. Just go around so you can see the frequency counter. So it's pretty much spot on. What you can do is probably with the aging of the crystal and parts, you could probably muck around with changing some bits and pieces, but I'd be very wary of doing that with a board of this age, because when I did do the replacement of parts, where was it? Yeah. Some of the board removed, so I had to scratch away and then had to bend the lead back and then solder it onto the trace of the board. So you just got to be careful removing some components. You know, this has been pre-done, it's been worked before. Not the neatest of jobs, but it will do. He didn't pay a lot of money for this, so it's just a bit of a hobby that he's going to do. What we also could do to adjust the frequency, just to move it a little bit more, we can place a capacitor, a fixed capacitor, across the trimmer. So if I wind it back, there's the trimmer there, and then we can add a capacitor there. I'm going to do that, but I'm also going to do some wire links just to show you the difference in output. So on the board where we've got 34 and 33, I'm just going to add some wire, some jumper wire, so I can then tap onto it and we can see it do 100 milliwatts and we can see it do the 1 watt. So let me just solder those in play and we'll have a look at that. So I'm back now and I've put a 30 picofarad capacitor across that trimmer. And we're just going to see if we can just do bring it in a little bit closer. I've also added 2 pieces of wire and tin the ends, and that's across R33 and R34, just to prove the point that this can do more power. So if I plug the power back in, let's get the antenna, just pan back over there. So as you can see, it's on the 1 watt scale. It's probably going to go past that, but we'll have a look. And I'll do the frequency first just to see if adding the capacitor has made much difference. So it was 1610.0304 and now we've got 1610.0001. So that's made a bit of a difference. You could probably try and trim that a bit more, but adding that capacitor has done the job. If I then just pan up a little bit, I'm just going to let's turn it off, take this off, turn it back on again. And if I take these 2 jumper wires that I put on, and then we're just going to connect them, there you go, go up to the next scale. We're doing about 1.5 watts with this one. So I'm just literally, you could probably add a switch and switch it in or out, but there you go, it's doing about 1.5 watts. Not recommended because the heat dissipation from these is not great, and you're going to start to the board with this colour. Could it damage the board further? Probably. So I'll remove that now. I'm going to take these wires off. I'll leave that capacitor on because that's made a bit of a difference. But hopefully this video was useful, if you're trying to align a AM-25. Thanks for watching. 7-3.